Welcome back as we continue taking a look at probability. Today we're going to be talking about probability of a compound event. So we have some key ideas to remember. First, a compound event means that two or more events will occur. So when we're talking about a compound event, we're going to have more than one thing happening. And to find the probability of compound events, we must multiply the probability of each event together. So remember, compound event, more than one thing happening, and in order to figure out what that total probability is going to be, we're going to need to multiply them together. So now let's take a look at the two different types of compound events, starting with independent events. So looking at independent events, we need to remember that the probability of the second event is not affected by the outcome of the first event. So whatever happens first, it doesn't matter, it's not going to affect the second event. So now we're going to go through and we're going to circle all the examples where that is going to be the case. So when we're talking about rolling two dice, that's going to be an independent event. One dice is not going to affect the other dice. If I roll one to the left and one to the right, the outcome of one, if I get a 4, is not going to determine whether I get a 4, a 5, or a 6 on the other one. So rolling two dice is independent events. Selecting a card and putting it back, that's also going to be an independent event. If I take a card out of a deck, I have taken 52 cards, now I only have 51. I'm going to put the card back and I have 52 cards again. So it's not going to affect the next time I pull a card because all the cards that were in the deck the first time are in the deck the second time. The next example, selecting a candy and then eating it, that is not going to be independent. If I eat one of the candies, I've now prevented the next person from getting that candy. It's going to change the total number of outcomes because now there's less candy in the jar. So that is not an independent event. Flipping the same coin twice, however, is going to be an independent event because, again, no matter if I flip the coin 1, 10, or 100 times, I'm still going to have the same probability each time. Selecting a marble and then setting it aside is not independent because I've removed the marble from the jar and now the total number of marbles is different, so the total outcomes is different, so that's not going to be an independent event. And then spinning a spinner 2 times, that is going to be a independent event because the spinner is not going to be affected by each spin. The spinner is going to be different each time. So now let's do some practice with independent events. So here in example A, Alyssa has a fair coin and a number cube labeled 1 to 6. What is the probability she randomly flips tails and then rolls a multiple of 3? Write your answer as a fraction in simplest form. So here we're going to have two events, so we're going to need two fractions. The first one is a fair coin, and she's going to be flipping tails, so there's a 1 out of 2 probability that that's going to happen, 1 being tails, 2 being the total number of outcomes, and then a multiple of 3 on our fair number cube. So we know first that there are going to be 6 numbers on our number cube, and then we need to determine how many of those numbers are going to be multiples of 3. So if we're taking a look at our number cube, we've got 1, 2, 3, 4, 5, and 6. The only numbers that are multiples of 3 are 3 and 6. So since those are the only two multiples of 3, we're going to have 2 out of 6. Now, we need to multiply these two fractions together because that is how we find compound probability. I am not going to cross multiply them. I'm going to just multiply them straight across. Now, you can reduce your fractions ahead of time if you'd like. I'm going to leave them the same and reduce at the end. So 1 times 2 is going to give me 2, and 2 times 6 is going to give me 12. However, since it asks for a fraction in simplest form, I then need to reduce that fraction. 2 divided by 2 is 1, and 12 divided by 2 is 6, so our answer is 1/6. So notice I had to multiply straight across and then reduce my fraction. Could I have reduced my fractions before I multiplied? Yes, but I need to make sure that I have my fraction in simplest form at the end. Now let's take a look at example B. So here in example B, Harold needs to pick a 2-digit number for his soccer jersey. He can use the numbers 0 to 9, and the numbers can be repeated. If Harold randomly selects a jersey number, what is the probability that both digits are going to be odd? And it wants us to write our answer as a percent. So at the end, we're going to need to remember we got to turn our answer into a percent. But let's start by getting our first number. We need to figure out which numbers are odd, so I'm going to write out all of our numbers. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are our number choices, and we're looking for only odd numbers. So that leaves us 1, 3, 5, 7, and 9. So now we need to write down those number of outcomes. So it looks like we have 5 possible favorable outcomes out of, we need to figure out how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 out of the 10 numbers are going to be favorable outcomes. And again, we're doing this twice because we want both digits to be odd. So the first time, we're going to have 5 out of 10. And since the numbers are repeated, we're going to have 5 out of 10 the second time. Now again, I could reduce my fractions ahead of time, but since it wants our answer as a percent in the end anyway, it doesn't matter. Let's just multiply. 5 times 5 is going to give me 25. 10 times 10 is going to give me 100. And now I could reduce that to a simplest fraction and then make it to a percent. But since I'm just going to have to make it as a percent anyway, I can see 25 out of 100 is going to be 25%. Again, you could turn that to a decimal, get 0.25, and then move your decimal 2 places to the right or multiply by 100. Either way, you would still end up with 25%. So that is our final answer. So that's independent events. Now let's take a look at examples of dependent events. Now when talking about dependent events, the thing that we need to remember is the probability of the second event is affected by the outcome of the first event. So now we're going to go through our events here and determine which one of those are dependent events. So flipping 2 coins, they're not going to affect each other, so they are not dependent events. Remember, the second event is going to be dependent on what happens in the first event. Selecting a cookie and then eating it, that is going to be a dependent event. If you eat that cookie, the next person to go to the box of cookies cannot eat that one. It is already gone. So the total number of cookies has been affected and they can't get even that particular cookie because you've eaten it. Selecting a passcode when the number can be repeated. Again, that's not going to be dependent because you could pick any number the first time and you could pick any number the second time, so that is not dependent events. Rolling the same number cube twice, again, they're not going to be affected. The first number cube, whatever you get on it, is not going to affect the next time that you roll it, so that is not dependent. Selecting a marble without replacing it. That is a dependent event. If you take one of the marbles away, the total number of marbles has changed, so that is not going to be an independent event. It's going to be dependent. And spinning 2 spinners, they are going to be an independent event because they are not going to affect each other. So now that we've talked about dependent events, let's take a look at an example. Here in example C, Jack randomly selects a shirt, does not put it back, and then randomly selects another shirt. What is the probability that he selects a blue shirt and then a green shirt? So the important information here is that he wants a blue shirt and then a green shirt. So we need to figure out what the probability of getting a blue shirt and then a green shirt is. So first, we have to determine how many blue shirts he has, or how many shirts he has total in this graph. So I'm going to put a number above each column so I know how many shirts that we have. So we have 7 red shirts. It looks like we have 9 blue shirts. We have 5 green shirts. We have 12 pink shirts, and it looks like we have 3 orange shirts. So now that we know how many shirts are in each column, let's go about making our fraction. So he first chooses a blue shirt. So there are 9 blue shirts, as we talked about, and now we need to figure out the total number of shirts. So we're going to have to total up all of those columns. So we need to add our 7 plus 9 plus 5 plus 12 plus 3, and that should give us 36 total shirts. Now, he's taken that shirt and he's taken it away. He's going to have to pick a different shirt. When he takes away that shirt, when he removes it, now there is 1 less shirt. So we're only going to have 35 shirts remaining. We've taken away a blue shirt, so the total number of shirts drops. However, he's looking for a green shirt, so our number of shirts on the top is going to be 5 green. The fact that he took away a blue shirt doesn't affect the number of green shirts there are. Now, if he wanted to take blue shirts, both our numerator and our denominator would change because we'd be taking away a shirt from the total and taking away a shirt from the favorable outcomes. However, in this case, that is not happening. He is only removing a shirt from the total. Our favorable number outcomes in the green shirts stays the same. So now we're going to multiply our numbers together, and we want to get a fraction in simplest form. Now, we could multiply 36 times 35 and reduce from there, but that sounds like it would be a little bit hard to do, or it would take a lot of time. So I'm going to cross simplify first before I multiply. So I'm going to see that 5 goes into 35 7 times. So 5 goes into 5 once. 5 goes into 35 7 times. I'm also going to reduce on the other side. 9 goes into 9 one time. 9 goes into 36 4 times. And now I've got much easier fractions to multiply. 1 times 1 is 1. And 4 times 7 is going to give me 28. And now I've got a fraction in simplest form. So the probability that he selects a blue shirt and then a green shirt is 1 out of 28. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.